flower beetles. If they are left undisturbed in a warehouse, they can populate where they double in size every week. Okay, and this is the function that's used to show this. Okay, so one of the things they want us to do is they want us to fill out the table, and then we need to do some other things with the average rate of change. So first of all, at week 0, we're starting off with 25 flower beetles, that's what it says, and it doubles every week. So 25 doubled is 50, 50 doubled is 100, then we have 200, then we have 400, then we have 800. Okay, so that was pretty easy. Okay, calculate the average growth rate between weeks 1 and 3. Okay, so here's 1, here's week 3, here's our coordinates. We have 1, 50, and 3, 200. So if I'm figuring out the slope, I have y minus y, 200 minus 50 over x minus x. So this gives me 150 over 2, which is 75. So on average, there are 75 beetles per week. Okay, so what about this interval? We're going to go from 0 weeks to 5 weeks. Okay, so we have 0, 25, and 5, 800. And I'm going to find the slope, so I have y minus y, or 800 minus 25, over x minus x, or 5 minus 0. So this is 775, whoops, 775 over 5 gives me, I think it's 155. Yeah, 155. So this is significantly more. So why is that? Okay, so what we have here, and we can tell from here, is we have an exponential function. So if we were to graph it, it starts off kind of small and then whoop, it goes up really, really fast. So this first one, from the first week to the 3rd week, only goes up about that much. But if we go up to the 5th week, which is way up there, then we can see it's going to be much steeper. The slope is a lot steeper. All right. So you're going to have these kinds of problems on the homework and on the test. Okay, they give you a function. Okay, and you need to find the average rate of change in this interval. Okay, so again, these are both x values. So I've got -2 as an x value, and I have 4 as an x value. So how do I find y? I plug it in. So -2 times -2 is 4, minus 2 is 2. 4 times 4 is 16, minus 2 is 14. So now when I find the slope, I have 14 minus 2 over 4 minus a -2. That's going to add. So this gives me 12 over 6, or 2. Okay, this one's interesting. Again, I've got my x values. So -3 and 3. If I plug in -3 here, I get -3 times -3 is 9. Minus 2 is 7. 3 times 3 is 9. Minus 2 is 7. So some of you might see it here. What do you notice? The y's are the same, right? Okay, but let's use our formula. So m equals y minus y over x minus x. And I get 0 over 6, which is 0. Well, that's weird. There's no rate of change. So if I were to graph this, okay, this is a parabola that goes down 2. And I go to -3. So let's say -3 is here. Okay, and we go boop, 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 so it's about here. This is symmetrical, so So that means my 3 is going to be about right here. If you connect those, you have 0 slope. So it looks like nothing's happened. Now, something has happened in that interval, but I'm just looking at what's happened from the beginning to the end. Okay, that is what I have for you. This is just a picture of some Olympic guys running the 400 hurdles. This guy is insanely high. But anyway, let me know if you have any questions.